Hello everybody, I hope you're doing great. Today I've got something very simple for you and very useful. Newton's 3 laws of motion. I think that many of you have already an idea about these, and if not, I hope this video will be valuable. So let's start with the first law that says an object in motion will remain in motion and an object at rest will remain at rest unless acted upon by a force. Which means that if you want to move an object or accelerate it or even slow it down, you must exert a force on that object. And the bigger the object is, the harder it is to move it or to stop it. For example, the force I should apply on this book to move is much bigger than the force I should apply on this little mouse to move, because the book has a huge mass comparing to the one of the mouse. Briefly, the first law is all about inertia, and inertia describes the tendency of an object to keep doing what it was doing. In this example, the book has more inertia than the mouse. Now let's move to the second law. Net forces is equals to mass times acceleration. F equals to m times e. Here we're talking about the net forces, or you can say the sum of the forces exerted on the object. So if we consider this case where the Earth exerts a force on Anna, it's called usually the weight, thus denoted with P, and the force exerted by Amin, say F1, and finally the force exerted by the surface, F2. Let's say that Anna is in a state of equilibrium. In other words, let's suppose that E equals to 0. Obviously, F net will be equals to 0 too, which means in this case that P plus F1 plus F2 equals to 0. And according to the second law of motion, A equals to F divided by m. So if the mass increases, the acceleration decreases. Now let's move to the last law. For every action, there is an equal but opposite reaction. In other words, when you exert a force on an object, the object exerts an equal force back on you. In many cases, it's called the normal force. Back to the story of the book. Obviously, the book has a weight. Therefore, it exerts a force on the table. And what the third law of motion tells us is that the table itself exerts a force on the book backwards. Mathematically, we have P equals to minus R, which means that the weight of the book and the reaction of the table have the same multitude in opposite directions. So as you can see, these laws are very important in classical physics, and we still can use them in our daily life. These 3 laws were announced in Newton's book in 1687. Please, if you have any questions, write them down below. I hope this video was helpful. See you in my next video. If you liked this video, press like, and for more videos, press the red button below.